Our day-to-day lives increasingly depend on wireless connectivity for education, work, and play. Understanding the differences in available Wi-Fi bands across 2.4 GHz, 5 GHz, and 6 GHz can help you get the best speed, distance, and coverage for the wireless devices you use every day. Understanding 2.4 GHz vs 5 GHz vs 6 GHz. Understanding your wireless connectivity options starts with talking about waves, specifically radio waves, which are used by devices to exchange data between devices over the air. All waves have a pattern and can be described by a wavelength, the distance a wave travels before the pattern repeats itself, and a frequency, how many times the pattern repeats over a given time period. When talking about wireless connectivity, wavelength and frequency directly impact the amount of data that can be sent, the speed at which data gets from one device to another, and how far the data can travel. What's in a number? Radio waves transmit information over a specific range of frequencies, also referred to as the RF spectrum. For communications, specific groups of frequencies in the RF spectrum, or bands, are used. These bands can be further grouped into a range of sub-frequencies, called channels. The use of frequency bands and channels for specific applications, such as Wi-Fi, TV, radio, and air traffic control, is regulated by government agencies. The numbers 2.4 GHz, 5 GHz, and 6 GHz refer to the specific RF frequency bands approved for unlicensed wireless use. A lower number means fewer wave pattern repetitions over time, and therefore a longer wave with longer range, while a higher number means more repetitions that can transmit more data over shorter distances. For context, 1 Hz represents 1 repetition per second, and 1 GHz represents 1 billion repetitions per second. A simple way of understanding wireless connectivity is to think of each frequency band as a different type of road and channels as the number and width of the lanes each road can support. 2.4 GHz is similar to a one-lane country road that isn't designed for heavy traffic, but can take you farther into rougher landscapes. 5 GHz is like a multi-lane freeway that is commonly used as an alternative to country roads, and is often congested even though it's larger. And the latest band, 6 GHz, is much larger and has many more high-speed lanes that are exclusive to the newest and fastest vehicles. I don't consistently today,